So, what are odd and even numbers? How can you define them? I think we all kind of know what they are, but you come up with a definition. So, I'm going to pose, I've got a really interesting question here. Um, it's a scenario. It says during a gasoline shortage, Oregon adopted an odd and even system of gas rationing. Drivers with odd numbers license plates could get gas on odd numbered days of the month. Those with even plates could get gasoline on the even numbered days. Some people whose license plate ended in zero were confused. They said, well, am I odd or even? Is zero an odd or an even number? And again, that lies with the definition. So I'm going to share with you the definition of an even number and odd numbers. Take a moment, read this, digest this definition. So any whole number that has 2 as a factor is called an even number. Any whole number that does not have 2 as a factor is called an odd number. So really, odd numbers are essentially being defined as whole numbers that are not even. So if it's not even, then it must be odd. As long as it's a whole number that's not even, then it must be odd. Well, if you watch the last video, at the very end, we came across this question. Does 2 divide 0? And we said that as long as there's some number that when we multiply it by 2, it equals 0, then 2 divides 0. 2 is a factor of 0. And if it's a factor, if 2 is a factor of a number, then that number is even, which by definition makes 0 an even number, not an odd number. So thus, someone driving around Oregon with a license plate like this, they'd be getting their gas on even numbered days. So 0 is classified by the definition as an even number. And so in a moment, well, actually in the next video, you're going to be learning about different divisibility tests for certain single digit numbers. A way to see, is a number divisible by 2, 3, 4, 5, 6, 8, or 9 without actually doing any division. But before we can do that, we have to talk about and learn a few different properties of divisibility. And this might take you a moment to digest. So I suggest as we go through these, pause, just really stare and play with these for a moment. And also jot them down because I'm going to be referencing each of these 3 properties in the later video. So I'll refer to them as divisibility property 1, property 2, and property 3 for these 3. So property 1, here they all are, but I'm going to go through them each again individually. Okay, so property 1 again looks like this. We're just going to take a moment to talk about property 1, which says if a number divides each of 2 other numbers, then it divides their sum. So notationally, if A divides B and A divides C, then A divides B plus C. Okay. Visually, that looks like this. Again, maybe take a moment and pause and stare and let this sink in. So A is the number we're working with. A divides B. So A is a factor of B. And you can see here's the distance of A, right? There's some number and there's the distance. Here's that same number A. So there's that distance. It also divides C. So if you take B and C and put them right next to each other in a line, A, you can see them all here, is also going to be a factor of whatever those 2 numbers add up to, their sum. A will also divide B plus C. For example, we could say that, well, 3 divides 9 and 3 also divides 6. So 3 would have to divide 9 plus 6. 3 would be able to divide 15. Okay, 3 is a factor of 9, 3 is a factor of 6, so 3 is a factor of the sum of 9 and 6. Okay, and here's that worked out visually for you. So that's property 1. We're going to, again, use these properties to sort of analyze some of the divisibility rules we're going to learn in the next video. Here's property 2. If a number divides one of two numbers, but not the other, then it will not divide their sum. So unlike the last problem we just did, the last property, if 3 divides 9, but 3 does not divide 5, then 3 could not divide whatever 9 plus 5 is. 3 does not divide 14. Okay? And you can see that visually with a very similar diagram to the last one right here. A divides B, right? It fits in nicely to B, but it doesn't fit in nicely to C, right? You'll see C adds this little leftover space, right? So C is not a multiple of A. So if you put B and C together and add them up, A does not divide that sum. There's still going to be that same little bit of leftover space at the end, all right? So that's property 2 of divisibility. And then finally, that's not the right one. Here's number 3. If one number divides another number, then it will divide the product of that number with any other whole number. So you've seen this introduced before. We often use the letter K just to represent any number we're going to multiply by, okay? It's a really common use of the letter K. So this says if A divides B, then A divides any other whole number, again, as long as K is a whole number, times B. So can we think of an example? Well, 3 divides 6. We already did that one. Then 3 has to divide, I don't know, 4 times 6. Pick a whole number. Well, 4 times 6 is 24. And yeah, 3 does divide 24. You can pick any number you want right here, right? So as long as 3 divides 6, then you can multiply 6 by whatever you want. And 3 is still going to divide that number as well. Here's what that might look like visually. So if A divides B, and you string a bunch of B's together, doesn't matter how many there are, as long as it's a whole number, A will divide however long that entire line is, right? However many of those B's you string together, A is still going to divide it. Okay? So here are just a few more examples that illustrate each of those 3 properties, just to give you some other numbers. So let me make this fit just a little better. Since for property 1, and these are not numbered appropriately, this is 2, and this is 3. Since 6 divides 54 and 6 divides 48, we can conclude that 6 divides whatever 54 plus 48 is, 102. So 6 would divide 102. 7 divides 42, but 7 does not divide 50. So we can conclude then that 7 does not divide 42 plus 50, which is 92. 7 does not divide 92. Finally, 13 divides 26. So if we multiply 26 by any other number, like say 9, 13 would also divide that. 13 would divide 234, which is the product of 9 and 26. So again, those properties are really important, for us understanding some of the things we're going to talk about in the next video, which are divisibility rules.